All right, welcome back. We are in Khan Academy in Algebra 1, and the unit is quadratic functions and equations. This skill is called graph quadratics in factored form. So here it is. They tell us to graph the equation. They do indeed have it in factored form. That means that we have the greatest common greatest common factor here. And then the other factors that include the variable term are here and here. So negative 3/8 times x plus 5 times x minus 3 is our function. And we're told to graph it. Well, in order to graph this function, in factored form, the easiest way to do it is to find the zeros of the function. So that's what we'll start by doing. The zeros of the function are whatever x values would make y equal 0. Well, that would be if at least one of the factors equals 0. So x plus 5 equals 0 when x equals negative 5, and x minus 3 equals 0 when x equals 3. So I know that if x equals negative 5, this factor is 0, which makes y equals 0. So I'm going to put this point at x equals negative 5, right there. And then I need the other point to be at x equals 3. Well, it's too far to the right, so I'll pull this over until I cross the x-axis at x equals 3. I've done that. Okay, now because this is symmetric, if I change where that is at, vertically, where the vertex is, it doesn't change where the function intercepts the x-axis. If I change it horizontally, it does impact where the function hits the x-axis. So we know we need x to equal negative 1 in order for our x-intercepts, our zeros for our function, to be at negative 5 and positive 3. So if I put in x equals negative 1, if I substitute negative 1 for x, I can figure out where the y coordinate has to be for this. Okay, so x equals negative 1 implies that y equals, well, if x is negative 1, we get 4 times negative 1 minus 3 is negative 4. So negative times a positive times a negative is positive. 4 cancels with 8. So I get 3 times 4 in my numerator, but 2 cancels with part of that. So you might as well cancel common factors before multiplying, because you're going to have to reduce it anyway. So 3 times 2 is 6. My denominator is now 1. So this happens at y equals 6. When x is negative 1, y is 6. I just happened to get lucky and put that on the right spot, but we have the vertex at negative 1, 6, and the zeros at x equals negative 5, x equals 3, and we're done with that one. Next question. Try to be a little more efficient this time. Before we go on, does this parabola open up or down? We can know the answer to that question just by looking at the constant here. If it's negative, we're going to open down. If it's positive, we're going to open up, presuming that both of these are positive. Okay, so we have a parabola that's going to open down. It's going to have zeros where the x makes this term 0, so that would be at x equals negative 2. Or where x makes this term 0, x equals negative 8. Okay, so we need our point to go across the x x-axis at -8. And we need the other one to go across the x-axis at -2, which means this has to get pulled over to here. Remember, the vertex is halfway between those 2 points, so we know that the vertex is going to have an x-coordinate that's halfway between -8 and -2. That happens at -5. -5 minus 3 is -8, -5 plus 3 is -2. And then we need to find the y value, so we stick -5 in for x to figure out what is the function's y value when the vertex is -5. So let's look. So -5 here gives you -3. -5 here gives you +3. So we're going to do 1/3 times -3. That's negative times negative is positive. So that's 1 times 3 is 3. So this will happen right there. And we're done.